every educational divide.
So let's solve examples on what you have done so far.
So here we have a question which says we have to calculate the distance between each of the following pairs of points. First we have P and Q with their coordinates. B says point M and N and the respective coordinates. Then C says points X and Y, and then D says point alpha to point beta. Alright, so let's kick off. Let's start with the first question. First one says distance between P and Q, where P is on coordinate this minus 4, 5, and Q is on coordinates minus 3, 2. So let's kick off. From what we have now, our x1 is point x1 is minus 4, and point y1 is 5, and of course our x2 is minus 3, and y2 is 2. And the formula says that PQ should be given by equal to roots all of x2 minus x1 all squared plus y2 minus y1 all squared. Let's put the values inside here now. So PQ is given by square root of our x2 is minus 3 minus our x1 is minus 4. Close it and we square everything, plus our y2 is 2, our y1 is 5. Yes, we close it in brackets. Simplifying, we have that PQ, this is on a color, PQ equals to minus 3, then plus, this will give us plus 4 all squared, plus, are we correct? Yes, it's correct, plus 2 minus 5 all squared. Please advise you always let your solving be at the same level to make your work neat. Alright, so PQ equal to minus 3 plus 4 is simply 1 squared, okay, plus 2 minus 5 is minus 3, so minus 3 all squared. Simplifying further, we have PQ to be square root of 1 plus minus 3 all squared is minus 3 times minus 3, this is plus 9. So plus 9, we have root 10 units. We can leave it this way, or we can find out the square root of 10. Square root of 10 should be equal to 3 points. What? Let's find out. 3 points. Root 10 is root 10 3.16 units in 2 dp. All right, so next we have 2 points M and N with their coordinates. So as usual, our x1 is equal to 0, and x2, not x2, and y1 is equals minus 2. Our x2, that's x coordinate of the second point, that's the abscissa of M. Our x2 is minus 4, and our y2 is 0. So as usual, our mn, distance between m and n, or length of line mn, will be given by square root of x2 minus x1 all squared plus y2 minus y1 all squared. Let's put in the values. Our x2 is negative 4 minus our x1 is 0 all squared plus our y2 is 0 minus our y2, our y1 is negative 2 all squared. So we have that our mn equal to negative 4, negative 0 is still negative 4, negative 4 all squared plus negative, sorry, 0, negative, negative 2 is just simply 2. Yes. That will give us negative 4 all squared is that's 16 plus this is 4 which we can write as times 5 equals negative 4 is, sorry, square root of 4, excuse me, square root of 4, not negative 4, please. Square root of 4 is 2. We have this to be 2 with 5 units. Or we can write this as 2 times root 5 should be root 5. Root 5 is 2.236. So times, so it becomes equal to 4.4747 units into dp. All right, so we go to the next question, which is point x and point y. From here now we have that our x1 here is x1 is minus 1/4 and y1 is 1/3. Yes, 1/3. Then yx2 is minus 2/5 and y2 is minus 1/6. So that, of course, our formula remains that xy equals x2 minus x1 all squared plus y2 minus y1 all squared. So let's put in the values now. We have it to be, our x2 is negative 2/5 minus x1 is negative 1/4 all squared plus our y2 is negative 1/6, negative 1/6 minus our y1 is just 1/3 all squared. Simplifying, we have it to be equal to negative 2/5 plus 1/4 all squared plus this remains this way. Negative 1 over 6, sorry, squared here, minus 1 over 3 all squared. Going forward, so our xy will be equal to, now let's find the LCM of 5 and 4. Okay, let's simplify this. So let's simplify negative 2 over 5 plus 1 over 4. LCM is 20. 5 and 20 is 4. 4 times 2 is 8. So it will give minus 8. Plus 4 in 20 is 5. 5 times 1 is 5. So minus 8 plus 5 is that is minus 3 over 20. So the whole of this is minus 3 over 20 all squared. Yes. Let's deal with this. This other side will be negative 1 over 6 minus 1 over 3. LCM is 6. 6 in 6 is 1. 1 times 1 is 1. So negative 1. Minus 3 in 6 is 2. 2 times 1 is 2. So you have it to be negative 3 over 6, which is can be written as negative 1 over 2. So the whole of this is negative 1 over 2. So let's put that into our equation so that our xy remains negative 3 all over 20 all squared plus our this point is a negative 1 over 2. Of course, you're going to have it to be 3 squared is 9, all over 20 squared is 400. Don't forget that since we have negative number all squared, it's going to become to plus because negative a times negative a, this will give us plus, and of course this will give us a squared. So let's continue. Plus 1 squared is 1, 2 squared is 4. Let's simplify this. The LCM is 400. 400 is 1 times 9 is 9. Plus 4 in this is 100 times 100. Yes, that's 100. So we are having this to be root 109 divided by 400. Okay, we can write this as square root of 109 divided by square root of 400, which we have as root 109 all over 20, or 1 over 20 root 109. If you like, you can simplify further, no problem. I prefer to leave my answer this way. So units, you have units because that's a general term. We don't know whether it is okay a kilometer or meter or cm, but we will just use units. All right, thank you. Next we have alpha and beta. So in this case now our x1 is going to be, our x1 is this negative 0.5 and y1 is 1. Our x2 is going to be 2 and the y2 is going to be 0.4. Yes. So our formula remains that alpha beta, that's line alpha beta, is equal to x2 minus x1 all squared plus y2 minus y1 all squared. So putting the values now, we have our x2 is 2, minus our x1 is negative 0.5, plus our y2 is 0.4 minus our y1 is just 1. So simplifying further, we have this to be square root of 2 plus 0.5 all squared plus the same thing, 0.4 minus 1 all squared. So that we have that our alpha beta will be equal to, let's add this up. Yes, it should give us 2.5 squared plus this should I think negative 0.6. Yes, all squared. So we have this to be this should give us 6.25 plus I think 0.36. So let's add up. So we have it to be equal to square root of 6.61. Square root of answer square root of 6.61. So final answer becomes 2.57 units into dp. All right, thank you.